at the Aqua. He is a principally driven engineer leader who believes that great engineering organizations are built with those who deeply care about their customers or their teams, their tech. So currently runs three platform engineering teams at Acquia, the primary digital experience platform company who is transforming how brands create digital movements that matter. So they use Kubernetes and its ecosystem to build the next generation DXP. Previously, he was a teacher, professor, engineer, architect, senior manager, and the product leader. He also has past experience speaking at the open source conferences like this, so such as a DevOps and the public company conferences. And he has received a good feedback on the motivation, inspiring delivery. So I must say, Stephen, that we are gonna get the same motivation from this next session. Over to you, please.
Thanks, Pooja, and great session, Nicholas. That was great to see. Um, hey, ladies and gentlemen, like Pooja said, my name is Stephen Raganat. I'm sharing my screen here. If some of my operators can let me know if we're all set. Can everybody see it?
Yes.
Perfect. You'll have to forgive my virtual background. It's really early morning here in New York, and my other arrangements where I am right now fell through. They didn't open the door, so I'm in my car. Um, but we're good to go. So, yeah, today we're going to talk about, there we go, a tale of two engineers in Kubernetes. And I'm going to tell you a little bit of a story, and then we're going to go into why it matters. I already spoke about who I am, senior manager of cloud engineering, run a few platform teams here at Aqua. But who is Aqua? And what is a digital experience platform? If you're in the content management space or the digital experience space at all, you'll know of platforms like WordPress or Joomla or Drupal or Contenta, you name it. But basically, we build a platform where developers will come and build expressive, large-scaping, content-driven experiences on the internet. And our primary flagship product is for Drupal, but we also have machine learning projects, CDP products, um, everything you can think of around, really delivering that best-in-class moment online. Um, and that's me. And Pooja said, yes, I've been in the biz for a long time. Was a music teacher actually before that, so really looking forward to. So first, just to level set, to kind of tie some of this together, I thought a little bit of background was necessary on what we're talking about, because we're going to be talking about what we do. What is Drupal? So Drupal is a content management software. It's used to power some of the most prominent websites and applications that you might use every day. Great standard features like content authoring, reliable performance, excellent security. But it's really the most modular from an ecosystem perspective. So when you think of your package management or module management in Drupal, um, has a very, very wide base. But then when you look at the APIs of the actual system of Drupal, so if you want to extend what we call core, it's also extremely flexible, has some awesome, well-tested patterns in it, etc., and hook systems. It's really expressive, and that's why most enterprises choose it. When you think of who uses Drupal, I thought everybody was on WordPress these days. Actually, OSCONF's website is on WordPress or something like that, I think. But no trolling there, just because I'm from a Drupal company. But we're talking about like NASDAQ, the Olympics. If you're going to watch the Olympics in Japan, well, when it comes back, you think of federal governments, even in Europe and the Americas and Brazil and Singapore. You talk about Johnson Johnson, NASDAQ, Red Hat, Pinterest. These companies all use Drupal to power their online experiences. So that's what it does. So when you think of it, think of like, all right, it's like a lamp stack. I have modules and deployments and stuff I normally need to manage, and that's where Aqua comes in to help. So let's story time. A tale of two bricklayers. Maybe you've heard this one before, and sometimes it goes with three, but we're going to do two. You know, as the adage goes, you know, you're walking down the street and you see two bricklayers laying brick, and they're both at work. They're both moving pretty fast. I don't know if you've ever seen people laying brick. We actually are building an addition on my house right now, and so when they're laying brick, they have this like smooth motion. It's kind of like like an artist when they move with the thing. But he goes up to the first one. He says, "What do you do? What is it called?" And he says, "I lay brick. I take the mortar and I spread it out and make sure it has the right consistency, and then I place it down and I clean it up so it's nice and smooth, um, and so that the wall is strong. That's why I build brick or lay brick." Uninspired, the person goes to the other person and says, "What do you do?" And this other person says, "I love my job." Leaning in, you would say, "Why do you love your job?" And he says, "I get to build a place to worship my God," right? And realizing the onlooker sees that they're actually building a cathedral. And this person says, "I built a house of worship. Each day I come here and I take another step forward into, you know, finding and crafting a place where people will come and, have fellowship together. And to do that, I happen to lay mortar with a brick and make sure that the wall is strong." When you think about those two, expressions of the same job, we there's a lot of different ways that's been called in the past: missions versus mercenaries. A mercenary just does the job for money. A missionary does a job for a purpose, for a why. Um, and as a part of my organization, right, we always look for missionaries, people who understand why we do what we do, and then use the tools of the trade. Some of the awesome tools, like Nicholas was just showing, and I'm sure several others before I got up this morning were showing, to do amazing things for the world. And um, and so, when you think about what really drives, or what I'm really interested in, and what we're talking about today is really around like how do we get engineering to move into this direction of cathedral builders, and what does a role of Kubernetes play in that, and how is that even related, and where are we going with this? And I'm so glad Nicholas's talk was right before this. So, the tale of two engineers. It's the same thing, and Kubernetes. So here's description number one. Maybe some of us and even myself have had things like this on my LinkedIn page or my resumes before. I build a platform as a service that leverages the most powerful open source tools like Kubernetes. That's why we're here. The control plane provides multiple clusters that house hundreds of thousands of pods, deployments, and services. Each section of it provides scalable Drupal workloads with unparalleled performance and security. So that's a statement about the self of an engineer, and that's not bad, right? It's talks about what you do, the scale of what you do, the kind of feature sets that the system might provide, and it's not altogether bad, but I think it's missing one key component of that, right? It's missing the cathedral, and so if we compare that versus 1v1, right? Little PvP in engineering land here, it looks like this. I help digital storytellers tell their story to the world. I ensure their experiences delivered through Drupal are fast, secure, and resilient. And it utilizes Kubernetes, spanning hundreds of clusters and hundreds of thousands of pods, deployments, and services. I am a maker of the next digital age. So with this second one, while it's even a little bit shorter and maybe not calling out the platform as a service, it tells why we do what we do. And I think Kubernetes, and as Aqua being a 13-year-old company, evolving to use Kubernetes at scale, we've seen how this particular technology and the ecosystem around it really champion and give engineers a more expressive passive and native way to be more mission oriented. So what about Kubernetes? So this might be not new to anybody, but from right from their website, what is a Kubernetes object? An object is a record of intent. Once you create it, it'll constantly work to ensure it exists, like Nicholas's Java operator or controller at one point, right? By creating an object, you're effectively telling the Kubernetes system what you want your cluster's workload to look like, and this is your cluster's desired state. Now, fully transparent. Aqua does a lot with servers and services on those servers, what's running, and we actually, when you come and buy some stuff from Aqua, we're like sizing you up for what kind of servers you need, because we work with very large scale customers, and we actually make the business fit around the tech in a backwards way, in a non-mission oriented way. In the what? We actually sell you servers. And really what you want to do as a customer is, you want to pay for experiences. You want to deliver moments that matter, like Pooja was reading from the description. So you don't buy that. Instead, you buy the hardware to go and figure out how to do it. And a lot of our, and this is true for most platform companies, but platform companies will often have, their engineering teams structured in such a way that they, layer teams or whatever it may be, where, they specialize in a particular component of it. Like, I'm the database layer, I'm the compute layer, I'm the, edge layer, networking layer. You can see this in common companies who are maybe a little bit less application space like us, like Amazon or Google. Like, they have a Lambda team, an EC2 team, Google Kubernetes team, a Vision team for Google, right? And that's great when that's the product. The product is a developer product for a specific capacity. Let's call it a compute capacity, a EC2 instance, for example. And when I thought about, when we evolved into this new technical strategy using Kubernetes, and what we could do, a lot of our customers started asking, like, well, how are you managing the pods? How are you managing the PVs? And like, what happens in this scenario to, the replica sets? Does it go up? Does it go down? How are you controlling ingress? Which controller are you using? And I realized that's all the wrong questions, right? Like, you're asking about all the details, all the sausage of the sausage making, right? And then in exploring what our architecture should be, we came across, the operator pattern. I'm sorry if that's being cut off at the top. It is in my screen. I'm not sure why. So the operator pattern, which Nicholas was just talking about, aims to capture the key aim of a human operator who's managing a service or set of services. Human operators look after specific applications and services, have deep knowledge of how the system ought to behave, how to deploy it, and how to react if there are problems. Once again, that's from the official website. So, so when I thought about this, and I thought about how to build this next generation platform on Kubernetes, and when you think about our scale, it's not one cluster and a single application with a deployment. It is actually hundreds of clusters and hundreds of thousands of applications with, millions of sites. And we explored the operator framework because it gave us a way to model what is actually real for the business. That's what's real for Kubernetes. Kubernetes has this effect where, like, if you want to go and talk about how to solve a business problem, you talk about all the Kubernetes things. And we didn't want to do that. We wanted to solve the business problem with business things and have the system reflect that. It's probably a forever problem in computer science, right? They talk about the two problems in computer science, right? It's caching and naming things, right? What's the problem with naming things? instantly is a bad name, like 2 weeks after you name it. And that's because the actual systems and the code that you write under test here, under the business, are actually solving an actual problem, a business need. Of course, you need the mortar and the bricks to actually build it, but what you want people to see are not mortars and bricks, but cathedrals. And the operator pattern helps us do that. And I think, at a high level, just to level set, in case you're just jumping in, how do operators, or just Kubernetes scaling works in general, which we might get the feeling of, we might not understand it, but it actually comes from a systems programming aspect. And this is why operators are so powerful, and controllers are so powerful. So when we think about a specific aspect of Kubernetes replicas, there's two different types of systems for when you want to think about how to scale. And they're called edge triggered and level triggered. And edge triggered basically says, as events come into the system, you react. So it's more real time, but that might have an undesired effect on how scaling will work. And you can see here in the diagram, you could be like, I need 4 more, I need 3 less, I need this, I need that. And the system is constantly going back and forth of what that might do. And if changes were instant into the system, that might be really hard. That might be really easy, and it could be, edge triggering works a bit better when changes to the system are very easy. But when we talk about cloud computing and scaling up, downloading images if we have to, or using the cache and launching them, and whatever start time for the internal entry point for the container is going to be, or the pod's going to be, there is a bit of delay there, especially when you think about web scale or trying to go up or anything like that. You need to add resources. So what normally happens in your Kubernetes cluster is you have overhead, right? There's a certain set of capacity that is just inherently not used, so that you can scale a couple pods up into it. And as your autoscaler kind of works through that magic, it'll say, okay, great, I need some new instances. I'm going to launch a couple more, and then it's going to go ahead, and then you can schedule more pods on it. And even if you use some managed services, like Amazon's coming up with managed node pools using Fargate, it doesn't matter. It does that in the background too. And so level triggering is the exact opposite, right? Basically, instead of saying what to do to the system under load, so if you had 2, add 5, or add 3, right? You would just say go to 5, or go to 2. So you wouldn't say, what the operation is to get to desired. You just say what desired is. And level triggering means that your controller, instead of applying the action that you've said, it would automatically, at the point in time, calculate where you need to go, which ends up leading to more consistent, predictable scaling behaviors, in which operators do. So when you think about the life cycle of operators, or the different life cycle events that Nicholas was showing, on create, on delete, whatever that is, basically you're just reconciling. So you'll be able to, instead of, he called it what did you call it, Nicholas? It was like a dumb loop or stupid loop or something like that. It's kind of how it works, right? There's an absence of time, or recognition of time, rather, in which it will go ahead and continue to try and get to desired state accordingly. And there's a great post on edge triggering and level triggered, and how Kubernetes uses level triggering from James Bowes. So what did that tale of two engineers look like for Aqua? And so we had all of these things, and I'm going to show you kind of a snippet of what a customer's workload might look like at Aqua. But it went from all the nitty-gritty native objects in Kubernetes to really specific, really relatable objects in our business applications, environments, sites, databases, and commands. And commands are like crons, or one-off things that you'd want to do. And what we did is we took those and we translated them over using the operator pattern to be a fully fledged system. So these operators, much like you saw before, are running on each of the clusters. And I know this is really hard to see. We're going to zoom in a little bit, But basically, we abstracted from the business all of the concepts of Kubernetes, and we just said you have a Drupal application. It has 3 environments: a development, a staging, a prod, and it has sites on it. It has Pepsi.com and drpepper.com and mountaindew.com, but they're all sites of the same application. And when you want to go and see how the usage is going, you see it in terms of your those concepts: your environment, your application, your site. Our business also sees it that way, right? Like when our operations or support teams go in and they try and help debug with a customer, right? They see the same things. They don't see the underpinnings of how it gets to where it goes. We roll it all up because of these operators into the domain model that our business and our customers and our teams have. And that's really great. That's really great for a lot of reasons, because not only is that great for our external customers or internal stakeholders from an engineering perspective, but my engineering teams are now thinking, how do we accurately represent the business with what we're trying to design? And before, when it was less expressive natively, you would have to do one of 2 things, right? Like you'd either try to write a system of your own to express the business, or you do a lot of especially in the platform world, you might do something where like your REST APIs might have great modeling, like you have apps and environments and sites, and these are records in a database. But then when you actually wanted to translate that into like hardware, you had the hard part of actually doing what Kubernetes does out of the box, which is reconciliation of that. Meaning like, okay, if somebody makes a post request to create a new site on their environment, then I'm going to fire this call off to EC2. Or you might make it more resilient and say, I'm going to fire it to a broker who then has a system in case EC2 fails that it will actually create, and it'll be asynchronous. And then I'm going to have to describe it or pull it or something to make sure that it gets back. Or I fire a message back on the broker. It comes back and it says, okay, yes, it is done now. And then, you have to do all this stuff. But Kubernetes, it has that communication all built within, and that mental model of reconciliation that, hardware is hard, hardware takes time. And our teams are now focused on saying like, okay, there's a business model of this, and all they have to do is translate it. This means this. This means this. They're a translations team. So they're super focused on, obviously the underpinnings of Kubernetes, the brick and the mortar, the services, deployments, replica sets, finalizers, PVs, PVCs, and etc. Secrets. And on the other side, they also have to think like, well, the feature that we're really looking for this environment is that it needs SSH. They need to be able to connect and run, Drupal commands within it, drush commands, technically. And how might that translate into the Kubernetes context? And so they really have this dichotomy, this great dichotomy of this is really what we're doing, and this is actually how it's modeled. And the operator framework is actually a great framework to see it that way through, which leads to higher investment, engagement, and empathy for our customers with our engineers. So here's a zoom in, just in case you're curious of what it means when somebody says they have an environment, a site, a database, or command. Notice app is not here, but this is not one cluster. This is just a snapshot of a cluster. So you think, there's a namespace with ingress, route for it, and a few pods. There's memcache and secrets so that we can connect to databases that are external. How do we get SSH keys and various cron jobs and on demand, and another ingress for SSHD to come in through a proxy, etc. And all this is that translation layer, and you saw actually it in action with our last talk here. And it helps us do that. It helps us map that. And so when someone wants to like scale up or whatever it is, they're getting ready for maybe OSCONF is going to have its conference on May 16th. They want to scale up preemptively for their website. they just say, scale me up to a large or something like that. And then,
Stephen,
oh,
sorry
yes.
sorry to interrupt you in between. Actually, we are just running out with time, so we have just next 5 minutes. So
Yes.
it's sufficient for you?
Yes. I'm almost there. We're so close.
Okay, thank you.
Thank you so much, Pooja. Thank you. I am a talker, so sorry. But okay. So basically that's kind of it, a little snapshot, a glimpse into it. So we have teams of people right now working through building up a few operators, not just the Drupal one. We use Helm and Argo and Bonsai to manage hundreds of clusters, right? So we're using the leverage of this ecosystem of the Kubernetes and its surrounding ecosystem to really drive developer first development lifecycle for our engineers, but at the same time a business first lifecycle for them. Now, if any of that sounds familiar, it's actually common. It's been in circulation for a long time. Domain-driven design, if you've ever heard of it, it's a coding pattern that you might follow and has certain semantics, but it's all based on the same premise, right? To place the thing that you're creating at the core of why it's being created, not what it is, right? We didn't talk about, you don't write operators and describe it. Your APIs wouldn't look like bricks and mortar. They'd look like buildings, right? So overall, the operator pattern allows for our engineering teams to model our systems in a way that manages the mental model of our business for our customers. And it also gives our internal teams the common language for dealing with it. So why they don't think about the pods or namespaces or anything like that. Pods or, secrets and domain maps. We actually do give them access to, kget Drupal app or kget Drev, kget site to get some statistics on it, for example. And that my call to anybody watching is be a cathedral builder, right? With the tools that we got to explore today and all the awesome stuff going on in our open source community, you can, we're trying to take a page from your book as well. Hopefully you can take a page from ours. Use these tools to build what matters, and make sure that your systems represent the business and the problem that you're solving versus the tech that it's using. And that's the end of my talk. Thanks.
Okay, thank you so much, Stephen, for your skilled view on this.
Are there any questions? I'm not sure how I'd see them.
No, actually, there are no active questions, but in case of any, you can comment or you can share. You have already shared your details, so definitely people will get back to you on that.
Awesome. Well, thanks everybody. I hope you have a great rest of your evening, and thanks for this opportunity.
Thank you so much. So, guys, let's move ahead with our new speaker, Avinash Shrimali. So he's a senior member of technical staff. He's working in a VMware in a R&D department since 2008. He has total work experience of 12 plus years, which includes virtualization, QA, development in Java,